Welcome back to Med Madness, the podcast where we explore essential topics in medical education and practice. I'm your host, and today we're diving into the first part of our series on human factors engineering, or HFE. In this episode, we'll cover three key HFE strategies: forcing functions, computerized automation, and environment and physical layout. We'll also end with a case study to illustrate these concepts in action. Let's get started. First up, let's talk about forcing functions. Forcing functions are hard stops in a design or process that eliminate the risk of incorrect use. They are built-in safeguards that make it impossible to proceed with an action until a specific condition is met. For example, in anesthesia machines, each type of gas canister fits only one compatible socket and is not interchangeable. This design prevents the accidental administration of the wrong gas, ensuring patient safety. By implementing forcing functions, we can effectively eliminate certain types of errors. Next, we have computerized automation. This strategy involves using automated processes to remove human effort and variations that can cause errors. Automation ensures that tasks are performed consistently and accurately. A great example of computerized automation in healthcare is automated vital signs monitoring. Instead of relying on manual measurements, automated systems continuously monitor a patient's vital signs, reducing the risk of human error and ensuring that any significant changes are detected promptly. Now, let's discuss the environment and physical layout. This involves designing workspaces to facilitate correct actions and minimize errors. By optimizing the physical environment, we can create conditions that support safe and efficient care. Consider the layout of a medication room. Storing look-alike drugs in different locations can prevent mix-ups. For example, placing drugs with similar packaging or names in separate, clearly labeled areas reduces the risk of administering the wrong medication. Let's bring these concepts to life with a case study. Imagine a busy hospital pharmacy where medication errors were a recurring issue. The hospital decided to implement several HFE strategies to address the problem. Firstly, they introduced a forcing function by redesigning the medication dispensing system. Each medication drawer was fitted with a lock that could only be opened with a barcode scan of the patient's ID and the prescribed medication. This ensured that only the correct medication could be accessed for each patient. Secondly, they implemented computerized automation by using automated dispensing cabinets. These cabinets were programmed to dispense medications accurately based on electronic prescriptions, reducing the reliance on manual processes and minimizing human error. Lastly, the physical layout of the pharmacy was optimized. Look-alike medications were stored in separate, clearly labeled sections to avoid confusion. The workspace was organized to streamline the workflow, making it easier for pharmacists to locate and dispense medications quickly and accurately. As a result of these changes, the hospital saw a significant reduction in medication errors. The combination of forcing functions, computerized automation, and an optimized physical environment created a safer and more efficient pharmacy operation. In conclusion, human factors engineering strategies such as forcing functions, computerized automation, and environment and physical layout play a crucial role in enhancing patient safety. By designing systems that account for human limitations and capabilities, we can reduce errors and improve the overall quality of care. Join us in the next episode of Med Madness as we continue exploring more HFE strategies that contribute to patient safety. Thank you for listening, and don't forget to subscribe and share this podcast with your colleagues and friends. Until next time, stay safe and stay informed.